omega is 2 pi over t, or 2 pi f. Omega is 2 pi f, or 2 pi over the period. Good. Can you find the period? Yes. 2 pi the square root of m over k. Good. If I double the mass, the period will be longer or shorter? Longer. By how much?
4 times.
If I double the mass, by how much will be the period? Longer. If the mass instead of 10 kilograms, I put the 20 kilograms, what will be the mass? What will be the period? Checking the formula. If I double the mass, what will be the only difference with on the period? Will be a bigger number. By how much? By what factor? The square root of 2, which is how much? How much is the square root of 2? 1.41. 1.41. So will be longer by 1.41 of the original period. Any question on that? Good. This is this. So we found omega, we found t, we found the frequency. All this is so far. This was just the period. What will be B max? B max, you can use either. I mean, the formula we know, which is omega A. Since we have omega and you have A, you can find what will be B max right away, omega A. Or, if you don't remember, you can use here. EI is equally final because now there is no non-conservative force. There is no more P. So at the beginning, what energy? When it's maximum extended, what is the energy? Potential. K over 2A squared. At the point of equilibrium, can you find B max? Yes, will be the square root of K over MA. Since we have K, we have this is omega. We can find the speed at 7.5 centimeters. What can we say? If you want to find that, we will use to find V at that moment. What you will use? Energy perspective or oscillatory perspective with what the information given? Energy perspective. Because there is no non-conservative force, which of the three theorems? The third. At the beginning, EI. Where is EI? When you extend it, that's the initial moment. What type of energy? In the midpoint, what type of energy? And we have everything to find V. Any question on that? Good. We finished with that. E. Find the maximum acceleration. What will be the maximum acceleration?
Omega squared.
Times what?
Amplitude.
Times the amplitude. This is pretty much what I will ask from energy perspective. That part. I didn't touch the oscillatory behavior yet, except omega, t, and frequency, which is part of the oscillatory behavior of the spring. But now, the other typical question here will be the other typical question. So all these questions are from energy perspective. So from 1 to 6 energy perspective. All right? So now, the oscillatory behavior, which is the second part. Let's say that I give question number 1. and this is a typical question. A body of mass 5 kilograms is suspended by a spring which stretch 10 centimeters when the mass is attached. So when I attach the mass, it will stretch 10 centimeters. It is then displaced downward an additional 5 centimeters and released. Its position as a function of time is approximately, what do you think that will be your position as a function of time? You extend it and release. So when you put the spring, here, here you have the spring, and you have a mass. So this is the spring, and this is a mass. So when I put the mass, you can see that this will go 10 centimeters. It reached a new equilibrium position. If I want to find K, how can I find it? It went down 10 centimeters. How can I find K?